For blood test number 8 in 2024, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 17 years younger than the chronological. So what might be contributing to these data? So let's start off with prescription meds. For those who are unfamiliar with the channel, I was diagnosed with hypothyroidism in my 20s, so I've been taking levothyroxine, more specifically 137.5 micrograms per day, since then. Which then brings us to supplements. Now the first shouldn't be a surprise either, as I currently live in Boston, and for about 9 months out of the year, the non-summer months, I supplement with vitamin D. For this test, it was 2,000 IUs per day, and I did that for 52 of the 53 days that corresponded to this test. So what is the 53-day period that corresponded to test number 8 in 2024? Well, it started immediately following test number 7, which was on October 25th, and it lasted until the day before test number 8, which was on December 16th. So that's a 53-day period. And as we'll see in a minute for the diet data, I'm going to show 53-day averages for diet. All right, next up on the supplement list is nicotinic acid. As when I don't take any NAD precursors, my NAD can be very low as 20 micromolar or less. So for this test, I supplemented with nicotinic acid as very low doses raise my NAD by a small amount. I'm still trying to figure out what's the optimal NAD in terms of how high, whether it's 30 micromolar, 40, 50, etc. So for now, I'm still experimenting with data in the 20 to 30 micromolar range. Now, to get my NAD levels in that range, very low doses of nicotinic acid get me there. As you can see, I supplemented with 35 to 85 milligrams of nicotinic acid per day. And you could say, how am I getting a supplement in that low of a dose with varying amounts? So I'm not taking it in pill form. I bought the exact powder, nicotinic acid, and then suspended it in water. So I take aliquots of that every day, depending on how much niacin I get in the rest of my diet. So if I'm eating, like, for example, mushrooms, which are high in niacin, I cut down on the supplemental nicotinic acid while aiming for a specific total niacin intake level for a given day, around 100 milligrams per day for now. So with that in mind, rather than assuming that nicotinic acid supplementation impacts my NAD levels, on the same day as this test, so December 17th, I also sent blood to Ginfinity for NAD analysis. And if you want to measure your own NAD levels, there's a discount link in the video's description. So on the same day as all the other tests, for test number 8, NAD levels were 25.5 micromolar. And that's in conjunction with an average niacin intake over these 53 days of around 103 milligrams per day. Now, where the story gets interesting, though, is that for test number 7, my average niacin intake, including nicotinic acid supplementation, was about 86 milligrams per day, so a lower total niacin dose. But yet, NAD, on the same day as testing all the other stuff for test number 7, was higher at 32 micromolar. So now there are at least 2 factors going on here. One, the test-to-test variability is somewhere in the 5 micromolar range, even though nicotinic and niacin levels were in the same ballpark, 100 versus 86 milligrams per day. Or 2, there are other factors that, despite having a lower total niacin intake, allow my NAD to be higher than 26 micromolar, in this case, almost 32 micromolar. So I'm currently calculating correlations for NAD with diet, as I have 20 plus data points for NAD. So I can look at correlations with diet and then adjust my models for nicotinic acid intake to see which other factors may be involved in mechanisms that can raise my NAD levels. All right, that's it for supplements. That then brings us to diet. So more specifically, what's the diet composition that was the 53-day average that preceded this test? And that's what we'll see here. This is the average daily dietary intake for that 53-day period that preceded test number 8. Now, this list is ranked in terms of grams, with 2 exceptions. One is coffee, which is in ounces, and that's not 0.4 ounces every day. That's one 20-ounce coffee over this 53-day period. And I make it at home. I just put some coffee in a stainless steel bowl, boil some water, and pour that into a teacup, and it's pretty delicious. But I'm already getting caffeine from green tea, which is a staple in the approach. It's been a staple for probably 2 decades. And if you want to use what I use, which is organic loose leaf green tea sourced from Japan, there's a discount link in the video's description. So while we're on the topic of green tea, for those who are familiar with the channel, you might notice that usually it's 20 ounces for every test, as it's a constant. I fill most of the stainless steel ball with loose leaf green tea. And then again, it's just like the coffee. I boil water and put it in there, add some lemon, and I'm good. That's a 20-ounce cup. So it was 19.2 ounces for this test because for 2 of the 53 days, I completely removed it. No caffeine. And I did that to see if it would have an impact on how many times I awakened in the middle of the night, or if it would impact sleep duration and or slow wave sleep percentage or duration. And it didn't make a dent on any of that. So I'm now back to 20 ounces of green tea per day. So that brings us to experiments. What other experiments did I do for this test? And for every test, I'm making small changes with the goal of optimizing current weak spots without blowing up the rest of the diet. So for this test, there were 3 main experiments. The first was a reduction in flaxseed intake, and I did that based on a significant positive correlation between gamma tocopherol, which is a vitamin E isoform, with lipoprotein A. In other words, gamma tocopherol in my data is significantly correlated with a higher level of lipoprotein A. And the importance of lipoprotein A, besides its atherogenicity, is that it's a part of the epigenetic algorithm for Dunedin pace, with probably a higher lipoprotein A being associated with a faster epigenetic speed of aging. So to test that hypothesis for the past 2 tests, I followed the correlations within my own diet to try to reduce lipoprotein A. Now for test number 7, the main experiment was increasing cacao bean intake, which was inversely correlated with lipoprotein A. And for that test, lipoprotein A was 90 nanomolar. For this test, in following the gamma tocopherol correlation with lipoprotein A, when considering that flax seeds are my most concentrated source of gamma tocopherol, I reduced flaxseed intake with the goal of reducing gamma tocopherol intake to potentially reduce lipoprotein A. And note that I say potentially reduce because these are correlations and I don't know about causation. The only way I can test causation is by following the correlations. And even then, if the biomarkers move in the right direction, there too, it's still just a correlation. Many other factors may be involved. So for this test, I cut flax seeds to 12 grams per day. And note that the previous test, so for the period that preceded test number 7, it was 16 grams per day. And you could say that's not a major cut. Come on, it's only 4 grams. But for the 2 weeks before test number 8, average flaxseed intake was only 7 grams per day. So I cut it to more than half relative to test number 7. And in support of that approach, lipoprotein A moved from 90 nanomolar for test number 7 to 80 nanomolar for test number 8. And note that I did that despite cutting cacao bean intake from 12 grams per day for test number 7 to about 5 grams per day for test number 8. So after recalculating the correlations, clearly now cacao bean intake will be less strongly correlated with lipoprotein A, as keeping it relatively low was associated with a lower lipoprotein A. In contrast, flax seeds and gamma tocopherol's correlation strengthened, as cutting it was involved in the mechanism that helped bring lipoprotein A to a lower value relative to test number 7, 90 versus 80 nanomolar. All right, so other experiments included an increase in orange intake. For this test, the average was 58 grams per day, whereas for the previous test, it was 35. And I did that based on a significant positive correlation for oranges with DHEA sulfate. So DHEA sulfate levels declined during aging, and in my data, they've been mostly stable for the past 18 tests, 2.25 years. So I've resisted an age-related change within that time span. But going back 20 years, I have 2 data points with DHEA sulfate levels that were around 300. But I wasn't tracking diet back then, so I can't say what was going on. And I also know that I was supplementing with DHEA, which would be expected to raise DHEA sulfate. So I don't know if it was just youthful data. I don't know if it was because I was supplementing with DHEA. Nonetheless, it's possible that my DHEA sulfate has declined from a youthful 300 to around 125. Nonetheless, resisting age-related change and trying to get it as high as I can, if I can, is a part of the overall strategy. And to do that, I followed that correlation with oranges, with DHEA sulfate. And the good news is it was a bit on the higher side of my average, my recent average, that 18 test average, which is 125. So it was 128 for this test. So that helps to resist the age-related change. So that's somewhat good news. Again, whether that's causation, I don't know. All I can do is follow the correlations and try to best optimize my biomarkers like that. The third experiment that I did was increasing chickpeas relative to intake for test number 7. So I doubled chickpea intake, and even though this isn't a large amount, and I've got it in dry weight there, so from 9 to 19 grams per day, approximately double, I did see an impact on the biomarker that I was trying to move, which was creatinine. Creatinine is used as a biomarker of kidney function, and I already know many of you are going to say that it's not a good biomarker of kidney function. Before the age of 65, there's published data that it is. Above the age of 65, I would tend to agree, as it's proportional to muscle mass and kidney function declines, so cystatin C may be better. So in following the correlation for chickpeas with a lower creatinine, which would suggest better kidney function, creatinine moved to my 2015, my 55 plus test average since 2015, which is 0.95 milligrams per deciliter to 0.87 milligrams per deciliter. A small but probably significant move in the right direction, which suggests better kidney function. Now here too, I don't know if that's causation. All I did was follow the correlation. Higher chickpeas which is suggestive of a lower creatinine. The data moved in that direction. So it is what it is. So for these 3 experiments, there was good news. Reduced flaxseed intake, lipoprotein A came down by about 10%. Increased orange intake, DHEA was a bit on the higher side of my latest 2+ year average. And increased chickpea intake, and that reduced creatinine to my average since 2015, 50 plus blood tests since 2015. It reduced that to below average, again, which is suggestive of better kidney function. So good news for these 3 experiments for test number 8. All right, so what about cheat meals? So the diet isn't always purposefully clean. And I do that because in the past, historically, when I've tried to go completely clean and no junk and as strict as possible following the macros and micros indefinitely, if I can, I start to get to the point where I crave some junk. And not giving into that, I can do that for a short time with willpower. But eventually in the past, I've cracked, and then that can lead to a binge. And I'm trying to minimize binges as much as possible. That's the opposite of calorie restriction. That's the opposite of optimal health. So with that in mind, immediately after blood testing, I add some junk. And then I do that for a couple days afterwards. And I've since expanded that approach to 1 or 2 days with some cheat meals into not paying attention to macro or micronutrient targets for that 3 or 4 day period immediately after blood testing. And what that does is it enables me to have some satiety or to get satiated by eating some junk, whatever I want, chocolate or peanut butter mixed with chocolate or ice cream, whatever it may be, while also not being as rigid with the diet. I have to get this much beta carotene or this much vitamin K or calcium, etc. Now, for that up to 3 or 4 day period following each blood test, I get satiated, and I also have gotten to the point where I'm like, I'm sick of junk. I want to get back onto my usual approach because I enjoy eating like this. So with that in mind, following blood test, the last blood test, test number 7, I had the standard, which is peanut butter mixed with chocolate. So I melt the chocolate, add the peanut butter, and I add some sugar. And that's a homemade Reese's peanut butter cup, which is delicious. I look forward to it. And then I also made some homemade ice cream. So if you saw the last video in this series, the diet composition video that corresponded to test number 7, I had some Oreo ice cream bars, which I thought were ice cream bars until after I ate them. And then I realized they're a frozen dairy dessert, which didn't include any heavy cream. So with that in mind, and filled with a whole bunch of other chemicals. So it was like a chemical, a storm of garbage, right? So anyway, for this test, following test number 8, I decided to make my own ice cream. And I did that with heavy cream mixed with sweetened condensed milk, which I should say it's not actually sweetened condensed milk for this test. I boiled it in can after removing the label for 3.5 hours, which converts it into a caramel-like texture, which is known as dulce de leche. So heavy cream, dulce de leche in one jar. And then in another jar, I made heavy cream, dulce de leche, and raspberry jam. So I've got 2 homemade ice cream jars, little jars, that I did that for a couple of days. And that was pretty delicious. I might do that for a cheat meal in the future too. So when adding up those junk calories, from the chocolate chips, 687, for the sugar, 393, sweetened condensed milk, which is essentially all sugar, 314, and the raspberry jam, also basically all sugar, although there's a small amount of fruit in there, probably, 336. Total junk calories were 1730. And when dividing that by the total amount of calories consumed for the 53-day period that preceded test number 8, it is 1.5% of all calories. In other words, that 53-day average that corresponded to test number 8 was 98.5% clean and 1.5% junk. All right, so this list is ranked in terms of grams. What about ranking foods in terms of calorie intake? And that's what we'll see here. These are the top 10 foods for average daily calorie intake for the 53-day period average that corresponded to test number 8. And first, note that this image is generated by using Chronometer. And if you want to track your own diet using Chronometer, there's a discount link in the video's description. So atop the list, as it has been for many tests, are sardines. And that may change for the next test number 1 in 2025, as I've started to add in wild-caught salmon to get astaxanthin, which is a carotenoid. Now, astaxanthin was recently shown to increase lifespan in one of the many ITP studies. And astaxanthin has also been shown to have positive effects on skin and eye health. And these are two areas where I'm always looking to improve. So I'm going to add more wild-caught salmon into the approach going forward. Now, I wish I could add it every day, but that stuff is crazy expensive. The sardines that I eat are already somewhat expensive. I mean, this is like $15 to $20 a pound. Wild-caught salmon can be as expensive as $40 a pound. So I'm not going to add the wild-caught salmon in all the time, but it'll definitely make an appearance to get some, rather than none, astaxanthin into the diet. Now, in terms of the other foods that made the top 10 list, 9 of the 10 foods that are here were also here for test number 7 in 2024. As again, I'm not looking to blow up the diet at this point. I'm looking to make small changes while optimizing the weak spots and not messing up everything else. So with that in mind, walnuts entered the top 10, whereas flax seeds left the top 10. And again, for that lipoprotein A experiment. All right, so next up is macronutrient composition. How does that look for the corresponding 53-day period that preceded test number 8? So first, calorie intake. Average daily calorie intake was 2119. And this is my close to lowest intake since 2015. My lowest intake since 2015 is 2076 per day. So you could say, why not just go for your lowest intake? So eating less calories, in my case, being calorie restricted to some degree, is better and actually maybe the best intervention for all of my biomarkers. Something like a net of 10 biomarkers move in the right direction relative to wrong. And these are significant correlations with a p-value less than 0.05, with one exception. And that's lymphocytes, which decline during aging. So when my calorie intake has been at the lower end of my range for a few tests, I've had my lowest lymphocyte levels, and the odds of them being less than 1,500, which is moving towards age, as somewhere around 2,000, is what's found in youth, or more likely to be found in youth, and that's what's associated with a lowest all-cause mortality risk, is less likely. So with that in mind, that 2076 to 2119 may not seem like a big jump. It's only 40 calories or so. But for the past 3 tests, lymphocyte levels have been closer to 1900, and I haven't been at that 13 or 1400 range as I had been with the 2076 in that ballpark calorie intake. So going forward, I'm going to stay around 2100, try not to go below, with the goal of keeping lymphocytes relatively youthful and all of the other biomarkers relatively youthful too. All right, average daily protein intake was 96 grams per day, which when divided by total calories consumed is 18% of the total diet. Fat intake is shown here, 91 grams per day, which is about 39% of the diet. And then if you're interested in the individual breakdown of fat, monounsaturated, omega-3, 6, and saturated, that's shown here too. Next up is carb intake. So starting from total carbs, which is 268 grams per day. I know that seems like a lot, and I say that on every test, but net carbs equals total carbs minus fiber. Average daily fiber intake that corresponded to this test was about 76.5 grams per day. So when subtracting that from total carbs, we get a net carbs of about 193 grams per day. When multiplying that by 4 calories per gram, we get 36% net carbs that corresponded to test number 8. Now note that within fiber, about 20% of that is soluble fiber, which means that it's fermented by gut bacteria into short-chain fatty acids, including acetate, propionate, and butyrate. In other words, a fraction of fiber is converted into fat. And when accounting for that, 148 calories from fiber can be added to total fat. So that's 7% of the diet comes from fat that was potentially fermented by gut bacteria into short-chain fatty acids. So now we can see the net macros that correspond to test number 8. About 46% total fat, 36% net carbs, and 18% total protein. Now, note that within total carbs or net carbs, I also track sugar intake, and more specifically, total fructose. And that's because the diet is rich in fruits and vegetables, which contain fructose. And in my data, in those correlations, a relatively higher fructose intake is significantly correlated with a lot more biomarkers going in the wrong direction than right. So with that in mind, I keep an eye on fructose intake and try to keep it towards the lower end of my range. So for this test, when dividing sucrose by 2, as sucrose is half fructose, and then adding that to fructose, we get a total fructose intake of about 62 grams per day. Now that may seem like a lot. My lowest has been 48 grams per day, but the biomarkers weren't at their best. I think PhenoAge was 13 years younger relative to 17 years younger with a bit higher fructose intake for this test relative to the 48 grams for that test. But prior to that 48 grams, my lowest fructose intakes were around 57, 58 grams per day. So 62 is pretty close to my lowest. I've had fructose intakes that are as much as double where they were for this test. So this is progress, albeit not perfection. All right, micronutrients. How does that correspond to test number 8? So that's what we'll see here. And I wanted to get all of the vitamins, including the subdivision of the carotenoids, alpha and beta carotene, and so on the list. I'd encourage you to go full screen if you haven't already, if it's tough to see. Now, for anyone starting on this journey with the goal of optimizing biomarkers through diet and supplements, the first thing that I'd recommend is getting full RDA coverage for at least the first few blood tests. And once you're doing that, after a few tests, then you can start to look at correlations within your own diet and supplements, assuming you're tracking supplement intake too. And then you can start to follow correlations with your own data to try to optimize biomarkers towards youth and what's associated with lowest all-cause mortality risk. So with that in mind, if you look at my list, many of these micronutrients are purposefully much higher than the RDA as I'm following correlations within my own data, again, to try to keep those biomarkers youthful and associated with lowest risk of all-cause mortality. So I've highlighted this in other videos, but just go to the bottom there and you can see vitamin K is about 24 times the RDA, or what's considered an adequate intake. And I didn't pick that number out of thin air. Vitamin K is significantly correlated with more biomarkers going in the right direction than wrong. So I've been pushing it higher and higher over many tests to see if that would result in a better impact on biomarkers. And it has. So that's why I've settled on that high of an intake for vitamin K. Now, would that be true for others? I can't say. You'd have to track your diet, look at your own correlations, and then do that for many tests in order to figure out what may be optimal for each of the micronutrients rather than just following the RDA. All right, so next up is full list of minerals, and that covers the full diet composition for test number 8. That's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where you can see daily dietary data, including foods, macro and micronutrients, as I post that screenshots daily. So rather than waiting two months after each blood test, or around 2 months, to see the average dietary intake, you can see that daily data on Patreon. There are also a whole bunch of other tiers where I'm posting data, so if you're interested in that, check it out. And now I'm also happy to announce a new Patreon tier. What's optimal for biomarkers, including biomarkers representative of major organ and systemic function, including immune cells, inflammation, red blood cells and hemoglobin, metabolic health, liver, kidney, thyroid function, lipoproteins, and vitamin D. It's a 95-minute video, so if you're interested in that, check it out. Before you go, we've also got a whole bunch of discount and affiliate links that you can use to test yourself, which help to support the channel, including ultralabtest.com, which is where I get the majority of my blood testing done, clearly filtered water filter, at-home metabolomics, oral microbiome composition, NAD testing with Ginfinity, epigenetic testing, at-home blood testing with Cyfox Health, which includes ApoB, but also GrimAge, the DNA methylation test GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Diet Trying brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.